this video, we will cover the last section of Chapter 14. In most areas, water is treated before it's distributed for consumption, especially in urban areas, in cities and towns. Water is acquired from a natural source like a lake, river, or stream, and then treated to make sure that it's adequately pure and free from pollutants so that it can be consumed. In some rural areas, like farms and countrysides, wells are used to obtain water. In these cases, UV is often used to treat the water in one's own home. Water treatment plants use several steps to treat the water. The first step that's often used is to treat the water with slacked lime and aluminum. Once the water is treated with the lime and aluminum, a coagulate forms which traps a lot of the bacteria. The solution is then filtered through sand and gravel, or even charcoal, to remove some of the odors, bacteria, and aerate to improve the taste. After this occurs, a chemical disinfectant can be used to kill any remaining bacteria. Chlorine, for example, is used to treat pool water. In much lower concentrations, it's also used to treat drinking water. Ozone is another disinfectant that can be used to kill bacteria and viruses. In this diagram, we can see the entire process laid out. In the beginning, the water enters from a river, lake, or reservoir where it's treated with the aluminum and slacked lime. At this point, the gelatin can form and filter out some of the heavy particles and bacteria in the settling basin. It's then filtered through a sand filter to remove the gelatin and the heavy particles. After that, in a sitting pool, air is bubbled through. This bubbled air helps to remove any odors or smells and make sure that there's adequate dissolved gases in the water. Finally, chlorine is added, or any other chemical disinfectant that's desired, and the water is then ready to be distributed to the general population. Ultraviolet light can also be used to disinfect water. This is most effective on small-scale applications, which is why it's often used in residential areas that are attached to wells. It doesn't offer as much protection as chlorine or ozone, but well water is generally in pretty good condition to begin with. In many areas, fluoride is added to the water to help prevent tooth decay. This is a similar concept to adding iodine to the salt available at the grocery store. The tooth enamel is composed of calcium phosphate complex called hydroxyapatite. We can see the structure of this molecule in the chemical equation below. When fluorine reacts with the hydroxyapatite, it creates fluoroapatite. This is going to be a stronger ion and make the enamel harder and less affected by acids. The fluoride is added through a source of silicon hexafluoride or sodium silica hexafluoride at concentrations around 1 part per million. This is a fairly dilute amount of fluoride, but we still have seen up to a 50 to 70% reduction in cavities in populations that are using this fluorinated water. Water is a limited resource. In order to get the most out of the water from our natural resources, recycling water has become increasingly important. Before wastewater can be returned to the environment, or even used for a secondary source, it can be treated to remove the harmful contaminants that have built up during its primary use. In some of these wastewater treatment plants, there's up to 3 levels of processing that can be used before the water is returned to the environment. We can divide the wastewater treatment into three stages: primary, secondary, and tertiary. Primary sewage treatment involves holding the sewage in a settling pond to allow the heavier solids to precipitate out as sludges. In this case, we're primarily separating the liquids from the solids. The sewage passes through a screen to filter out the largest solids. Then in the grit chamber, some of the solids settle towards the bottom, allowing only the liquid to pass through into a sedimentation tank, which allows even more of the settled sewage to solidify at the bottom. The secondary treatment involves a sand and gravel filter to continue removing the largest solids. During this process, bacteria can also be used to break down some of the organic matter that is accumulated. Another form of secondary treatment exists called activated sludge. In this method, tanks are aerated with large blowers. The aeration allows for the activated sludge to separate from the clean water and aerate out some of the smells that are contained within the water. The final treatment for wastewater is tertiary treatment. This is the most rigorous treatment and involves charcoal filtration, reverse osmosis, filtration, or distillation. Not all wastewater is treated with all three levels of treatment. Depending on the desired use of the wastewater, tertiary treatment may be optional. For example, some water only goes through primary and secondary treatment and then can be used as reclaimed water for irrigation and sprinkler systems. Table 14.5 shows the maximum contaminant level for a variety of pollutants that can be found in water. In order for water to be serviced to the general public, it must have contaminant levels lower than the EPA required standards based on the Drinking Water Standards Act. Some of the byproducts along the way can also be reused or recycled. For example, the sludge from municipal sewage can be used as fertilizers. And a number of communities allow primary treatment in settling ponds, where the effluents can then flow into marshes that filter the sewage and use the nutrients that it contains. Some new technologies have even been developed, such as composting toilets that use no energy or water. In conclusion, water is essential to our quality of life. We must do what we can to maintain the quality of our water sources and to continue recycling and reducing the water that we use.